over to you, Padma.
All right. Thank you, Susan. Good day, everyone. This is Padma Chukai, and it is my pleasure to welcome all of you for our CSIG Thursday Talks. Please let me know if you are interested in speaking in this setting or know someone who you would like to hear from. So with a great delight, let me introduce Nico Abbatemarco, who is a research associate of practice on information systems and digital transformation at SDA Bocconi School of Management. At SDA Bocconi, he is part of the core team of the research lab Digital Enterprise Value. If you're not speaking, can you go on mute, please?
Right.
Okay, thank you. Research Lab, Digital Enterprise Value and Organization. His research activities focus on digital transformation and in particular on blockchain and distributed ledger technologies and their impact on the business community. Nico earned a Bachelor of Science in Finance and a Master of Science in Management, both from Bocconi University in Milan. He has also been a visiting student at National Taiwan University in Taipei, Taiwan. I guess he's a global trotter here. With that, let me give the stage to Nico. Thank you, Nico.
Thank you, Susan. Thank you, Padma, for the introduction. And thank you, everyone, for attending my presentation. I am Nico Abbatemarco. I am a research associate at SDA Bocconi School of Management. And in particular, in SDA Bocconi, I work at DevLab, which is the digital transformation lab of the School of Management. And together with my colleagues, Gianluca Salviotti, which is faculty deputy of the information system at Bocconi, and Leonardo Maria De Rossi, we produced this paper called A Structured Framework to Assess Business Application Landscape of Blockchain Technologies. And I'm not gonna explain what blockchain technology is, because it will be a long presentation. I'm gonna explain what we discovered while studying the landscape of all the blockchain application today available on the market. So this will be briefly my agenda. And I will start from the background. So why did we decide to start study blockchain? Because there was a humongous hype effect. 2017 was the year when the global market of cryptocurrencies exceeded $160 billion of market capitalization. The overall investment in the blockchain-focused startup were going to start, and several big names from the supply side of market, for example, such as Walmart and Maersk, for the first time entered into this new technology. Moreover, we discovered that most of the efforts of the academic community in the last 5 years were dedicated to discover what were the obstacles slowing the adoption of blockchain technology. But we wanted to focus the attention on what it is actually possible to do with blockchain technology. And there are now new organizations such as the Blockchain Institute, the Institute for Blockchain Studies, which are trying to answer this question. And on the basis of their work, we decided to trying to establish a framework to catalog all the blockchain protocols. So what we do is to build this framework starting from three, let's say, main technical details, governance details, and business details. To fill this framework, then we analyzed a database of 460 blockchain protocols gathered from two different sources, CoinMarketCap and Crunchbase, to maintain a good compromise between the completeness and the significance of the sample. We decided to exclude all the protocols with the market capitalization inferior to $500,000 at date, which was the end of July 2017. So this is the framework that we built. For the technical side, we have the consensus mechanism. The consensus mechanism deployed by the protocol. On the governance side, we have the distinction between permissionless and permissioned blockchain, so the type of ownership of the protocol. And on the business side, we refer to type of application, the task actually performed by the protocol, and the reference industry, the industry affected by the application itself. So we started from decentralized consensus. A brief introduction to blockchain is basically a network distributed database whose nodes, the participants in the network, continuously record information in blocks, which are consequently assembled in a unique chain. To realize the operation of assembling blocks, it is necessary to solve the so-called Byzantine general problem, which is to find an algorithm that ensures that all the users agree on the current state of the ledger. And the decentralized consensus was for the first time introduced in the most famous blockchain protocol, which is Bitcoin. And one deployed by Bitcoin is the proof of work. With time, other two main algorithms were, let's say, deployed. One is the practical Byzantine fault tolerance algorithm, or PBFT, and the other is proof of stake. And we decided to compare some of the characteristics of these three consensus mechanisms. So, for example, PBFT is works better in a limited environment, only with trusted nodes, but allows for a higher number of transactions per second and has the low latency. On the contrary, proof of work and proof of stake can work in an untrusted landscape. So they can support an unlimited number of nodes, but at the same time, their scalability is more difficult. The number of transactions they can handle is lower and the performance is worse. Then we decided to observe the ownership of a blockchain protocol, because blockchain protocols mainly divide into two big categories: permissionless blockchains and permissioned blockchains. Permissionless blockchains are protocols where everyone can read, send transaction and participant or information in general and participate in the consensus mechanism without asking permission to anyone. And they are always open source, meaning that the algorithm can be improved by anyone deciding to that can apport an improvement to the protocol. And they are mostly appropriate when a network is really decentralized, because they can assure a higher degree of transparency and a higher level of individual anonymity. However, this came at the cost of a higher energy requirement and lower speed. And the two most relevant examples of permissionless blockchains are Bitcoin and Ethereum, which probably you have heard of. For this kind of blockchain, we found that the most appropriate consensus algorithms are proof of work and proof of stake. On the other side, we have permissioned blockchains. A permissioned blockchain is a protocol which permission to read, write, and participate in the consensus mechanism is kept centralized to one or more authorized users. So it's only usable in a trusted environment. Of course, these trusted nodes can be restricted or applied to an arbitrary extent. And this enables a greater efficiency in terms of transaction velocity, but at the same time, they cannot be deployed in a completely decentralized environment. And the most significant examples of permissioned blockchains are, in this moment, Hyperledger and Ripple, which is actually not even really permissioned, it's semi-permissioned. And for this kind of blockchain, we found that the most appropriate consensus algorithm is the PBFT, the practical Byzantine fault tolerance algorithm. Then we decided to explore the really application landscape. So what is possible to do with blockchain today? And analyzing the existing literature, we found 7 main areas where blockchain was being used. So the first is, and they are not in order of importance, they are just in alphabetical order. So the first we studied is advanced tracking. Advanced tracking, because blockchain can be used with the IoT in an IoT environment. What does it mean? That today we are going more and more towards an IoT world, an Internet of Things world where everything is connected. And this kind of connection can be very dangerous because it leaves open a lot of space for an hacker to enter. So it is necessary to build a network that is safe, is secure. Blockchain was main characteristic are immutability, transparency, and security can help create this safe network. Moreover, they can help create decentralized network because today the few IoT networks really working are working on a centralized, let's say on the centralized paradigm, the server client paradigm. While in the future, when we will need transaction or information exchanges to happen in a few seconds, we will need decentralized networks that can work without a centralized system. So, blockchain facts. Pros, the blockchain can help create a highly resilient ecosystem with a high level of security and reliability. However, we are not sure that immutable storage of data cannot turn into a problem with time. And we'll see this pro and this cons will be mostly the same for all the application. Second application is data certification, which is probably one of the simple use cases with the blockchain. Why? Again, blockchain can assure immutability, security, and transparency. So it can be used very easily to produce databases to assure that databases are not being tampered with and that the data right on the database are time-stamped, so they are in an unalterable state. This is a perfect solution to avoid frauds, and it can help building database in countries where there are no such registry today, or where entities that should keep the database safe are not really trustable. And for example, there are many projects. There is one in Africa trying to establish a title deeds registry. And blockchain can bring frauds and counterfeiting resistance, can bring immutable registers, but at the same time, it is not sure that certification authorities will not be required, because certification authorities might be part of this mechanism, and today they are not. So, third application can be cloud storage. Inspired by the mechanism of Bitcoin, where a large network of users share its computational power to allow the protocol to work, other thought, why can't we share other resources through blockchain? And cloud storage is one of the first idea. The idea that users can host their surplus storage and purchase extra storage from other users. This will allow some really interesting improvements compared to the cloud storage service of today, such as, for example, the possibility to achieve a higher grade of decentralization, eliminating the possibility of single point of failures, and allowing a higher privacy and security level, because no user would store all the data, but only encrypted fragments differently from today. This will also allow, from the consumer side, a significant cost reduction, because blockchain storage cost, for example, Siacoin is a cloud storage service based on blockchain, and is actually very cheap compared to other cloud storage system. We are speaking about $2 per terabyte per month, compared with Amazon, which is $25 per terabyte per month. And so, also in this case, what blockchain allows is real redundancy, eliminating single point of failures, and higher level of privacy and security, at the cost of immutable store some kind of data that maybe you don't want to store immutably. Then we can maybe to the most important blockchain-enabled application, which is cryptocurrency. Why the most important? Because actually blockchain is born with cryptocurrency. Blockchain is born with the Bitcoin, which is the first blockchain protocol. And Bitcoin main function is to enable peer-to-peer transactions between users. Cryptocurrencies are not a new concept. They are digital money. What is new is that the mechanism of issuance of money and the settlement of transactions does not happen in a centralized way. There is no central entity, no central bank, no commercial bank working on these transactions. Users themselves are the responsible. And cryptocurrencies, which mostly use open source algorithms, can be used to facilitate the creation of financial peer-to-peer networks. And the global market is improving very fast, is expanding very fast, is continuously growing. And in September 2017, it exceeded $170 billion US dollars, a sum that reached a peak in December and then started going down from February and until today. And what are the cryptocurrencies facts? Cryptocurrencies require no central authority, give open access to everyone, are no country specific, and guarantee a high level of security, censorship resistance, and settlement. Meaning that in a country where a banking system is still not developed, they can be really useful. However, there is still not enough regulation regarding cryptocurrencies. And this lack of regulation can easily turn into a problem because cryptocurrencies are highly volatile and their anonymity can represent the problem. They have been accused, they accused Bitcoin many times of being used only for illicit transactions. Another really interesting application is digital ID through blockchain. Because today, identity verification systems need to require a centralized storage of identity documents, while blockchain can offer a different system and an efficient way to capture, share, and verify information between two parties. And this can be a very relevant breakthrough to create easy way to open a bank account, to set up utilities, to pay taxes, to buy a car, and guaranteeing at the same time a high level of security, a high level of accuracy of the data, and easy accessibility. And guaranteeing also different breakthrough, like for example, the possibility of through blockchain. However, also in this case, there is a serious problem of lacking regulation. And so, until we will not have the certification entity of today using these services, they will probably not develop enough. Another really interesting case is that of energy management and distribution. Because, for example, blockchain could be used to develop a peer-to-peer energy market. If we think today to the market of energy, there are users who produce renewable energy, which have to sell them, to sell the energy to the Central Trading Energy Authority. Because the Central Energy Trading Authority is the one that can buy from them when they have it in excess. While in the future, blockchain could allow to create microgrid where users can share their energy and sell or buy it between themselves, enabling a lower grade of dispersion of energy and lower prices. And however, it is very difficult that being the energy, big energy company in possession of today's grid, it is very difficult that individuals will enter this market soon. And finally, financial transactions. Financial transactions are a big application of the blockchain technology because they can dramatically optimize business processes thanks to a secure system of data sharing. And in particular, most relevant application could deal with remittances, peer-to-peer transaction, cross-border payments. And for example, one of the most famous leitmotif related to blockchain is that of banking the unbanked. Because blockchain could bring financial services where today there is no banking system. However, also in this case, again, there is a high volatility of cryptocurrencies underlying the services, and the lack of regulation has obstacled the diffusion of financial transaction services through blockchain. And so, what are the results of our research? We tried to classify blockchain numerically by application, and we found that cryptocurrencies are the most present blockchain protocols, followed by financial transaction. You can see that there are more than 7 application areas. That's because while we were scouting blockchain protocols, we found that there were many more application realized through using blockchain as a breakthrough, as for example, gaming services, or peer-to-peer content distribution services, or advertisement services. And the most used consensus mechanism in permissionless blockchain is PBFT. The most used in permissionless blockchains is proof of work. And our database were composed mostly of permissionless blockchain. So of course, overall, proof of work results to be the most diffused consensus mechanism today. Distribution by industry. We can see that most of the services realized through blockchain today are referred to the financial services industry, and principal due to the presence of the cryptocurrencies in that category and financial transaction services. While consumer services mainly refer to certification and gaming services. Then we decided that maybe a numerical analysis was not enough to explain the current blockchain landscape, and we decided to perform a market analysis. To perform a market analysis, we had to discard all the permissionless blockchains, because the only data publicly available were that of the permissionless blockchains, and in particular those listed on CoinMarketCap. And we referred to market capitalization as of the sum of all the tokens emitted in a protocol. For example, Bitcoin market capitalization is the sum of the value of all the Bitcoin currently in circulation. So we discovered that actually the market landscape is very different from a simple numerical landscape, and the Bitcoin alone counts for 48% of the market, followed by Ethereum at 20%. Actually, this digit changed by the end of the year, with Bitcoin being at around 35% and Ethereum at 30%, and Ripple becoming the second cryptocurrencies in the market. And also the application landscape changed a lot. Cryptocurrencies are still the #1, but they are very much developed than all the other applications realized through blockchain. At the second place, we find smart contract platform, which received the most of the attention during 2017, because on smart contract platform, it is possible to build all the other services that make use of blockchain. So what are our conclusion? That in 2017, the standard status quo blockchain protocol is a permissionless proof-of-work based cryptocurrency, which account for over 60% of the market, and proof-of-work is the algorithm used in over 50% of the protocols. We are still in a Bitcoin dominance phase, meaning that Bitcoin is the most relevant blockchain project, the one with the greatest economic impact, with a capitalization equal to 48% of the entire market. And it must be remembered that Bitcoin represented alone all the blockchain protocols by the end of 2016. And in many cryptocurrency exchanges, that is where common people can buy cryptocurrencies and acceding to the related blockchain protocols, Bitcoin is the reference currency, not the USD, or sometimes Ethereum is the reference currency. In any case, what we saw is that the system of blockchain was flourishing, and there was many protocols being developed, and there was many areas where blockchain could have had a big impact and could still have a big impact. For example, advertisement services, digital rights management services, and the predictive market analysis. which are some of the examples we analyzed. So this is mostly it. If you have any question, please tell me. Thank you.
Thank you very much, Nico. There are some questions already. Where smart contracts fits in your taxonomy, for example.
Can you repeat, please?
Where do smart contracts fit in your taxonomy? Do they just are they cross-cutting or?
Yeah, so actually we realized another work on blockchain, which is because we developed a research, 1-year research in the lab, entirely focused on the blockchain, on the technical aspects, on the governance aspect, on the tools enabled by blockchain. And this is a 1-year-long blockchain research, and the paper is just part of the research. So the smart contract, we found that smart contracts are the main tool enabled by blockchain, and actually digital tokens are only one kind of a smart contract. So where do we place a smart contract? We weren't sure to locate smart contract in a category, because actually smart contract, all the application make use of smart contract, and smart contract platform are the one like Ethereum where it is possible to develop smart contract, while all the others are applications that employ smart contract in order to work. Such as, for example, in the advertisement case, people can receive a payment, let's say, can receive a payment in the advertisement token if they decided to look at one advertisement instead of another. And this is regulated through a smart contract. Or, for example, in the IoT ecosystem, IoT object can communicate to each other, and this communication is regulated to smart contracts, through smart contract.
Thank you, Nico. And as we see also, Elizabeth has commented in the chat, smart contracts are the business logic so that the transactions in the blocks call, so applicable to all categories. Any more questions, anyone?
Like, for example, I can see in the chat now from Todd Arnold, it is impossible to use Hyperledger without smart contracts. This is true, and Hyperledger, in fact, we classified Hyperledger into the smart contract platform category, for example.
Great, great. Any other remarks from anyone in the chat or Billy? I see someone's unmuted themselves. Nope. Yep. Okay.
Hi, Nico. Here. Just thanks for the very helpful talk, and I just wanted to congratulate you again for getting that ISAP Best Paper Award at KICS conference. So thanks for sharing the presentation again.
Thank you very much. Thank you very much.
And please thank Nico in the chat if you enjoyed his talk. And any more questions, comments? I see also Justin has put a link to the IBM code patterns around blockchain. IBM has some, like something it calls code patterns, and to help people get started with the technology in a hands-on way. That's in the chat. Any other remarks from anyone? Nope. Okay. Well, that was. Oh, okay. Yep. Here it comes. I see a question. Yep.
Okay. So, any work on optimizing the number of blocks? Actually, the number of blocks is not an issue. The issue is how fast you can assemble the block into the chain. And so, for example, Bitcoin is developing a second layer solution called the Lightning Network, which is working actually off chain to solve this problem, to allow only a part of the transaction to be settled on chain, and so to sort of bypass the problem of needing time to add one block to another. Ethereum is trying to work on other solutions, for example, on sharding, but they are still developing this solution, because actually today the biggest problem probably in the blockchain world is that a blockchain is not fast enough to handle transaction that, again, are intended as just sum of information, like information exchanges. And if I need action to happen in a very few seconds, or even less than a second, I need a system where I can put one block next to each other in a very small time. And there are other solutions being developed to solve this problem. For example, one is to use permissioned blockchains, which making use, like Hyperledger, which making use only of a limited set of nodes, trusted nodes, can handle block generation in a very small time. Or other solutions are going far from blockchain, like, for example, using some of the blockchain exploits. IOTA, I don't know if you have ever heard the project, is developing a new consensus mechanism called DAG, Directed Acyclic Graph, which is like a blockchain without blocks, though using some of the blockchain characteristics. Okay, I can see other questions.
Thank you, Nico. That was great. Oh, you have another question. How big is the payload? Ooh.
Yeah. I'm gonna answer to Siddhartha first.
Okay. Go.
Yeah, payload can become very huge. Like the blockchain can become very huge, and this is a very relevant problem. Again, I will do the Bitcoin example because it's the most famous example and the easiest to do. Blockchain example weighs now a few hundred gigabytes, and while it is still manageable by many users, it will become not manageable in the next few years. So they are trying to find a solution to put less blocks in the chain and to handle most of the transaction off-chain. So to assure security and transparency on the main level, which is the on-chain level, but allowing most of the transaction to be settled on the off-chain layer. So that, for example, I don't have to settle every transaction. Like, for example, if I have to go to the bar to take a coffee, I don't have to settle that transaction on-chain, but the sum of 1,000 coffees bought at the bar, I will settle them on the blockchain, on chain. So to reduce the number of blocks, at the same time the payload on the blockchain. So to have a faster time for acceptance of transaction and a lower weight of the blockchain itself. Okay.
You're going to try for another question?
Yeah. The number of blocks and the IoT sensor and object. That is absolutely a problem. Because, for example, there are many references to advanced tracking through blockchain and IoT connection, IoT platform through blockchain. But IoT platform today cannot be realized with blockchain exactly for the problem we just mentioned. And probably advanced tracking is one field of application where today permissioned blockchains are still better. Permissioned in one sense. If you consider blockchain as a technology, it does not make sense to realize a fully permissioned landscape, because otherwise you could have just used a common database. Blockchain is useful when you decide to remove the central party, to remove a central authority, and to expand to create an ecosystem, a network of different parties. So for example, if you want to create an IoT supply chain, you can use a permissioned blockchain because it can easily handle the large volume of IoT signals, but you must extend at least that supply chain to all your, from the producer to all the supply chain to the customer. That makes sense. If you want just to use blockchain, the supply chain, and limited it to a single company, you would probably have a better time and have less difficulty just in using a common database. Okay.
Great, Nico. People are still asking you questions. Wow.
Yeah, I'm trying to answer one at a time.
Okay. So someone asking, how do you see the future of private blockchain versus public blockchain in enterprise environment?
Okay, this is a very good question because actually I am more for the public blockchain, but only if they have sense. Because what I looking at the blockchain ecosystem throughout 2017, I've seen that permissionless blockchain have been created out of nothing and received ton of financing. Like, I don't know if you ever heard of ICO, initial coin offering, which is the main system through which a new permissionless project have been financed throughout this last year. But most of them don't really make sense. And most of them confirmed to be a scam, a fraud. And what can be done with permissioned blockchain is, as I already said, open an ecosystem which is today closed and try to communicate with other partners. To use blockchain in general, be it permissioned or permissionless, you have to think in an ecosystem perspective. You cannot decide to use blockchain just for yourself. It won't make sense. You would have it would be easier to use a common database. But if you try to think in an ecosystem perspective, for example, let's say the case of many energy companies try to communicate with each other to settle energy transactions without having to go through a central bank. That could be useful and can be still done with a permissioned blockchain. Because you don't need any individuals to take part in the system, but you have still created an ecosystem where more than one partner can take part. And so I believe that many of the disruptive innovation will be brought by public permissionless blockchain that will enable different business models. Like, for example, Bitcoin. We couldn't have thought of a digital money without a central bank before the introduction of Bitcoin. But permissioned blockchain, I believe permissioned blockchain can bring a less disruptive innovation, but still a good degree of innovation throughout the enterprise. And we are working currently this year on another research, which we named Blockchain for the Enterprise, to discover how enterprise can handle the power of blockchain to enhance their processes or to bring a better product to their consumers, to their customers.
That's great, Nico. I think we ought to end the call now because we've got 10 minutes over, but I'll leave the chat open for a bit longer. And also, I think we'll invite you maybe later in the year to talk about your enterprise blockchain activity.
Okay.
Once yeah, why not? Why not? Maybe to see what news you have for us then. So once
Sure.
again, thank you so much. You can carry on chatting with people if you have the time for another few minutes, and I'll close the call.
Thank you very much. Thank you to everyone for assisting.
Thank you. Thank you.